Hello, am I audible? Sir, start? Yeah, good evening, sir. Shall I start, sir? Yeah, thank you, sir. Good evening, everyone. Am I audible? Friends, please confirm me. Yes, sir. Thing is that today I'm not at my place. I'm taking session from somewhere else. So maybe there will be little background noise, right? Yeah. So, friends, today I'm going to talk about the correlation and regression, right? And my video will also be not on because I'm using my mobile data and I'm not having here the Wi-Fi availability, right? So my video will not be on today. I'm just sharing my screen. Okay, my screen is visible.
Yes, ma'am.
Shall I start? Screen is visible. Yeah, thank you, ma'am. Okay, so it's day 9. That is the second last day of this FDP, where I'm covering correlation and regression. I'll start with the term correlation. Correlation is nothing. It is a statistical tool which helps us to find the relationship. So it helps to measure or find the relationship between variables. Fine? Just a minute. Okay, so when I say correlation, it helps us to measure the relationship between the variables, specifically the two variables, right? So this is known as correlation. When you want to understand the relationship between the two variables, you need to understand, you can only understand what type of relationship two variables are sharing. So we can say it is also helping us to understand the strength and direction of relationship. Strength meaning is the degree of relationship. So I can say, to understand the degree of relationship between the two variables and the direction of relationship, we are performing correlation. Degree meaning is up to what extent two variables are related, and direction means in which direction the variables are having a relationship, right? So this is what we can do using the correlation. When we talk about the measurement of correlation, that how we can measure the correlation, so there is a very famous statistical tool known as Pearson's coefficient of correlation. So using this, we can measure the correlation between the variables, right? So Pearson's coefficient of correlation generally we are using to measure the relationship between two numeric variables, right? So when the variables are numeric in nature, in that case, we can use Pearson's coefficient of correlation. Apart from that, if we are having the ordinal variables, that is, you have measured the variables on the rank scale, ordinal scale, in that case, we can use the Spearman's rank correlation. For nominal scale data, we can use Kendall's tau, right? But I think mainly we are focusing on the numeric variable relationship because in statistics, further we need to go for performing the advanced statistics when we are having the numeric variables. So we want to understand what type of relationship is shared by these kind of variables, right? So we can say we can represent the coefficient of correlation by small r. So coefficient of correlation can be represented by small r. The value can be, if you know the value of r, it lies between -1 to +1. So r can be between -1 to +1. That means the minimum value of r can be -1 and the maximum value of r can be the +1. Right? So r can be any value between these two figures, or between these two extreme values. So the extreme value of r can be either +1 when you are going upper side, when you are going lower side, we can say it is -1, right? If you talk about the interpretation of this, so when we say the interpretation of r, it is depending upon the value of r. So usually when r is -1 or, sorry, it's minus, not underscore, -1 or +1. So meaning is that we can say it is perfect relationship between the variables. It is perfect relationship between the variables. Perfect meaning is that two variables are almost identical in nature. When it is -1, -1 is indicating the negative relationship. So you can see -1 meaning is perfect negative relationship. +1 is perfect positive relationship, right? So you can see this thing. That means minus and plus are indicating the direction of relationship, right? Further, if r is in between 0.75 to 1, in this case we are generally calling it as strong relationship. Again, if plus it is positive, if minus it is negative relationship, right? Between 0.5 to 0.75, it is moderate relationship. Then when it is less than 0.5, it is weak or low relationship, right? So this way you can interpret the values of r, whatever values you are getting. In this particular range, you can find where that value is falling. Accordingly, you can interpret it. Now talking about the types. So usually in the statistics, there are varieties of correlations available. For example, simple, multiple, partial, then linear, non-linear, positive, and negative. So these are the varieties of correlation available in statistics. So these are the varieties of correlation available when you talk about the statistics, right? When I say the first one, the simple one, simple correlation is what? When you are having, or when you are interested to measure relationship between the two variables. So this kind of correlation is called simple correlation. In case of multiple correlation, we want to measure the relationship between more than two variables. So when we are measuring the relationship between more than two variables, we can call it as a multiple correlation. In case of partial correlation, we will measure the relationship between a few variables by keeping other variables constant, right? Linear correlation meaning is what? It is helping us to measure the relationship which is linear in nature. That is, we want to measure the, or we can say that when you say linear relationship or linear correlationship, we can say the proportion of change will be same. Proportion of change meaning is what? Means if you are changing one variable by 1 unit, other variable is also changing by the 1 unit. Or maybe if you are changing one variable by x unit, other variable is also changing by x unit, we can call it as a linear relationship. But when this proportion is not same, right? So when proportion is not same, proportion of change is not same, it is known as non-linear relationship. Talking about the positive correlation, so positive correlation meaning is that when the direction of change is same. That means if you are increasing one variable, other variable is increasing. When you are decreasing one variable, other variable is also decreasing. So when direction of change is same, it is known as positive correlation. But when the direction of change is not same, so we can call it as negative correlation. So when you are increasing one variable, other variable is decreasing, it is known as negative. For example, demand and price. It is very known example and very, what I can say, we have also experienced this example. If I say demand and price. So we know this thing when we are observing that price is increasing in the market for any commodity or product. So generally the demand gets decreased, right? So we can say the direction of change is not same. One variable is increasing, other variable is decreasing. It is known as negative correlation. I hope all are clear what the 6, 7 I have explained. All the correlation types are clear. Yes. Is it clear, friends? All are clear? Am I audible?
Yes, ma'am, audible.
Fine. So, Hari sir, it is clear to you and others?
Yes, ma'am, it's clear.
Fine. So, I think types are clear, meaning is clear, how we can measure is clear. Talking about the assumptions. So, when we say assumptions of correlation, generally correlation is we can say generally 30 pairs of observations are required to perform correlation. Right? Then the dependent variable should be normally distributed. Although I must what I can say, I must say this thing here. When we talk about correlation, correlation is not discriminating any variable as a dependent or independent variable, right? For correlation, these are whatever the two variables are taking, those will be only the two variables for correlation. The correlation is not discriminating that this will be dependent, this will be independent. Why so? Because correlation is not the capacity of measuring the causation. Correlation cannot say this is the cause or this is making cause of changing in the other variables. So that type of study we cannot do using the correlation. So that is why generally it is not differentiating between the dependent and independent variable. But as I told you, correlation is a building block in statistics, and for the further advanced statistical analysis, we need to generally understand the relationship type between the variables. So we are performing correlation, right? So for that purpose, maybe in future or maybe after performing or understanding correlation between the variables, you want to further treat those variables as a cause and effect relationship kind of thing. In that case, you need to understand which variable you are going to treat as a dependent variable, right? So for that purpose, if you are further treating them, so you need to decide which will be your dependent variable, and for that you need to check its normality and outliers also, right? So that way we can say these are the assumptions of correlation. right? So this is the one thing. Last thing about the correlation is that correlation is not a causation. Correlation is not a causation. Causation meaning is that cause and effect. Correlation cannot discriminate between the two variables as cause and effect. That means which variable is cause and which variable is effect. That type of discrimination or differentiation cannot be done by the correlation. So that is why correlation is not a causation. Correlation is only helping us to understand the type of relationship two variables are having, right? Now, if I talk about the R, in R, how we can perform correlation? So for that, firstly, we need to assume the two variables, right? Suppose sales and advertisement expenditure. I think not much, what I can say, tough for understanding these two variables. Sales, we all know. Advertisement expenditure, we all know. Because I think we are looking so many different soap operas on television, or maybe when we are going to the watch any specific movie or something. Even in the multiplex also we can observe so many advertisements are run, right? Even when you are going on the various social media platforms, there also we can observe the various advertisements were run by the or generally telecasted by the broadcasted by the marketeers, right? So that it can create awareness among the consumers or customers, so that they can understand what kind of things are coming in the market, or whatever the product is coming, what type of features it is having, what is the price, and etc. These kind of things generally highlighted in the advertisement, right? So purpose is very simple. Why companies are investing heavily in the advertisement? That is because they want to increase their sales, right? So the purpose is to increment in the sales. So we can say these are the two variables we were considering here to understand the correlation. So anyone who can tell me which variable will be here the dependent, which variable will be here the independent. Although for correlation is not needed, but still, if I want to discriminate between these two variables, which variable I can take as a dependent and which variable I can take as an independent? Anyone? Sales and advertisement, two variables I have taken. Anyone who can tell me which variable I should take as a dependent, which variable I can take as independent?
Dependent variable and advertisement independent.
Okay, advertisement is independent. Harry sir, this is what you said.
Yes, ma'am.
Very good. Thank you. Very true. Sales is affected by advertisement. So I can say sales is the effect, right? And advertisement expenditure can be the cause. So it can be the independent variable. It is a cause. This is effect, right? Now to perform this, suppose we are creating one vector for sales. Some figures I am taking here. So 16 I have taken. I am removing one. Suppose now I am having total 15 observations for the sales. Next, I am creating advertisement expenditure. So the amount which I have taken here for the sales, suppose maybe it is in 1000, right? So I will check now the length. It is 15 observations we have taken. I want to perform the correlation. So firstly, I will formulate my null hypothesis here. There is no significant relationship between sales and advertisement expenditure. Right? This is my null hypothesis. Now to test this, I am using the function known as core.test. Right? I need to pass my two variables. So I'm taking here advertisement expenditure and sales. So I hope you can see in the console window we are getting the output. There you can find. There you can see at the last line of this, you can see the output, last line output is saying COR. COR is indicating 0.8060, right? So what I can say that the R is this. So if R is 0.8, I think it is in between 0.75 and 1, and symbol is positive, it is not negative. So what I can say, it's a positive relationship, positive strong, I must say. So it is positive strong relationship between the variables, right? Now you can notice one more thing, that is you are getting the T and its P value also. So what is the purpose? So this T and its P value is helping us that whether the correlation is significant or not. So to understand the significance of the correlation value, we are having the P value, which is coming from the value of T. So that looking at the P value, if you can see, we can say it is less than 0.05. So if it is less than 0.05, meaning is that the correlation is significant. So what we will do, we will reject the null hypothesis. And when I am rejecting the null hypothesis, my conclusion will be that there is a significant correlationship or relationship between the two variables, sales and advertisement expenditure. So this way you can perform correlation, right? I think it is easy to understand, not tough. Yes. Is it fine? Friends, it is okay?
Yes, ma'am.
Shall I go for the regression now?
Yes, ma'am.
Fine. So now I'll talk about the regression. So regression is a step ahead. Correlation is only helping you to understand the type of relationship two variables are sharing. Positive, negative, strong, moderate, low kind of relationship it is telling you. बच्चे इन बच्चों को थोड़ा सा So now I'll talk about the second thing, that is the regression, right? So regression, as I said, it is a step ahead from the correlation. Correlation can only confine with the type of relationship two variables are sharing. Now, if you want to understand the cause and effect relationship, you will go for the regression, right? So we can say regression is a statistical test which can help you to measure cause and effect kind of relationship, right? Or we can say when you want to forecast your dependent variable based on your independent variable, you are talking about the regression. Apart from that, you can say that when you want, apart from that, you can say when you want to model variables, in that case also, you can use the regression, right? So that way you can say there are multiple uses of regression. So regression is very important statistical tool, right? So we can say, means I think it's a time of AI and we have heard about the machine learning and all. So we know in the machine learning, generally regression is used and there are so many algorithms which are based on the regression, right? So regression is useful in terms of it can help you to understand the cause and effect relationship. It can help you to understand, forecast your dependent variable. Also, it can help you to model your variables. So these are the multiple uses of regression, right? So we can say now we are talking about the type of relations, type of regression when we say statistics. So in statistics, generally there are two types of regression: simple and multiple. This is I'm talking in terms of linear regression, right? So type of linear regression I'm writing here. Apart from that, I think in statistics there are almost 50-60 types of regressions available. I'm only talking about the linear regression here, which is of the two types, simple and multiple. When I say simple regression is what? It is helping you to, or when you are considering simple, when you are considering two variables, right? It is known as simple regression. In this case, both the variables will be numeric, right? Whereas two variables, one more thing, one IV and one DV, right? In case of multiple regression, we will be having more than two variables, right? That is one dependent variable and more than one independent variable, right? And in case of multiple linear regression, your dependent variable will be numeric and independent variable will be categorical or numeric or both. Because we are having multiple independent variables, it is possible maybe one variable is independent, one variable is categorical. Likewise, maybe all dependent, maybe all categorical, maybe all numeric. Such kind of combinations are possible when we are talking about the independent variables in multiple linear regression, right? Till here I'm clear. Is it fine?
Yes, ma'am.
Yeah. Now, moving ahead and talking about as I said, we can fit or we can model the two variables, right? So as I'm talking about the simple linear regression, suppose. So when I want to model two variables, suppose you are fitting a line, right? So maybe we can say we can fit a line. We can fit a line between two variables, right? So we can fit a line between the two variables. That means we are doing a modeling. So generally it is linear. So we can call it as a straight line we are fitting between the two variables. So I think in the school days we all have studied the equation of a straight line. Anyone who can tell me what is the equation of a straight line?
Y is equal to mx plus c.
Very good. It is y equals to mx plus c. We all have studied, or maybe here I'm writing y equals to ax plus b, or a plus bx maybe. Is it okay? Fine?
Yes, ma'am.
Yes. So when I'm saying y is equals to a plus bx, meaning is that y is my dependent variable, right? Or maybe output variable, right? Then a will be intercept, b will be slope of x, or we can call it as a coefficient of x, right? Then x will be the independent variable, right? These are the notations we all have, I think, studied in the school days, right? Till 10, we all have, I think, gone through the mathematics. We all have studied this. But when we talk about, this is a mathematical equation, I must say, right? When we talk about the statistics, so we are adding one more term here, which is known as E, right? E is what? E is the error term or residual, right? So what happens, because as I told you, we are predicting the dependent variable using independent variable, right? So as suppose I want to take the example I have just taken in case of correlation. I have taken the example of sales and advertisement expenditure. So suppose companies are hoping if they will invest in the advertisement, so probably this much will be the sales. So maybe they have hired some analysts to forecast the sales when they are on the basis of the advertisement expenditure, right? So on the basis of advertisement expenditure, they want to see what will be the sales. So that means they want to predict the sales. So suppose the analyst helps them to predict the sales of the company and some figure is communicated by him. Accordingly, company has planned everything, right? And that way, they are waiting. So suppose for the next month, the analyst has made the prediction for the sales, right? Now, suppose it is set by 1000 units, or suppose it is in terms of unit. If suppose I'm saying the sales will be 1000 units, right? But if suppose when the actual month came and it is passed, company has seen or company has found that the sales were suppose 900 units, right? So in that case, forecasted value was 1000. Actual was the 900, right? So E is nothing. E is indicating you the difference of actual and predicted. So it is the difference of actual and predicted value, right? Is it clear? So it is 900 minus 1000 is minus 100. If suppose analyst predicted 1000 units, company experienced 1050. So the difference will be 50. That is the error term, residual, right? So it is indicating the how fit your model is or how accurate your model is. If error terms are more, residual value is very high or high, in that case, we can understand this thing that the model is not that much accurate, right? So accuracy of the model is less. So that is why nowadays so many algorithms are being generated by the analysts so that they can control the residuals, or they can make a algorithm which can be take us to very close to the actual figures, right? So that way it is known as error term or the residue. I think yesterday sir was asking to me, it is Harrison. So sir, now it is clear what is the error term or residuals.
Yes, ma'am.
Is
It is
it clear?
clear.
Yeah. Yeah. So error terms or residuals are playing very important role in the regression. When you talk about the assumptions of regression, so many of the assumptions are based on the error term. So suppose now I'll write the assumptions. Assumption number one says, first assumption is generally both numeric variable, as I'm talking about the simple linear regression. Second says no multi-collinearity in independent variables. Generally, this assumption I think I can skip because it is mostly applicable in case of multiple regression, where you are having more than one independent variable. In that case, you will talk about the multi-collinearity. In case of simple linear regression, we will be having a single independent variable. So that means you do not need to talk about the multi-collinearity there, right? Then you need to check the normality of residuals. Your residuals should be normal, right? Then you need to write the fourth one says residuals should be independent of each other, right? Then we will talk about the fifth says residuals should have equal variance, right? So these are the some of the important assumptions which you need to check when you talk about. Apart from that, one more I missed, which is variables should be linearly correlated, right? So these are the some of the assumptions which you need to check when you are talking about the regression. So once you will look at the assumptions, I think you can find almost 3 assumptions are based on the residuals. That means it is the scene of after performing regression, because regression, once you have performed, only that way you can see the residuals, right? So you need to check these things after performing the regression. Till here I am clear, everyone?
Yes, ma'am.
So shall I go for now performing the regression?
Yes.
Fine. Yeah. So I think I already talked about, there is one terminology or one data set named as empty cars. Do you remember, sir? Sir, it is in your memory. I talked about the empty cars data set. If you can recall, on day 2 or 3, something I told you. Suppose I'm writing here this. So what this will do for me? It will give me the information about the empty cars, that is motor, train, car, road tests, where you can find these are the multiple variables available, right? Now, I want to use, suppose, this data. So what I'm doing, I'm storing this data into the object named as data, right? So if suppose I want to see the first 6 rows of my data, You can recall I told you there is a function called head, which is showing you the first 6 rows of your data, right? So that way you can see. Now, suppose I want to see, there are 2 variables here, MPG and WT. What is MPG? MPG is miles per gallon, right? WT is what? It is the weight of your engine. I want to see whether there is any relationship or whether the weight of the engine is impacting its MPG or not, right? Right? Fine. So I'll write firstly the null hypothesis. Before this, can anyone tell me which will be my DV, which will be my IV here? Yeah. MPG and weight. Which variable I can take as a dependent? Which variable I can take as independent?
MPG
Sorry?
TV.
MPG is? Sir, MPG is?
Dependent variable.
Independent?
Dependent.
Dependent. Very good. Thank you. MPG is dependent variable. So it is quite obvious. Weight will be the dependent variable. Right. If this is the clarity we are having, I can write easily my hypothesis as there is no significant impact of weight of engine on MPG of car or four-wheeler. Is it fine? Miles per gallon of car. Is it fine?
Yes, ma'am.
Okay, so this will be my null hypothesis. Now, I want to see, as dependent variables are clear, independent variable is clear to me. Now I want to perform regression, right? So suppose I'm writing the name of my object, regression, sorry, result, or maybe regression result, right? I need to use a function called LM. LM is a function, linear method function. This can help us to perform regression, right? So I'll open and close the bracket. Now, this is asking me to give the formula. Formula is what? I need to write the name of my dependent variable first, which is MPG. Tilde I will use, and I need to use my independent variable, which is weight. Now I'm running this. So it is giving, yeah, it is giving me the error. MPG is not found. So meaning is that I need to write here data. Although my data is one of the argument inside the LM function, means you need to give the direction to the R that these 2 variables are coming from which data set. So although I have stored my empty cars into the data object, so the data parameter will take the object as data. I think now it will resolve the problem. Okay. I have run. Yeah. I have made any mistake. You can check. Empty cars correctly was written. Yes. Okay, fine.
It
Yeah.
should be MPG instead of MGP.
Oh, fine. I have made a mistake. Thank you, sir. MP. Fine. Yeah, it has run. Thank you so much, sir. So it has run now. You can see, you would be able to see the success of this particular line. That means we are not getting any error in the console, right? Now, suppose I want to see now the summary. You can see the complete summary we are getting in the console. So I'll explain you what the summary is saying to us. So we can find Firstly, for the residuals, the minimum residual value is minus 4.5432. The first quartile value of the residual is minus 2.3647. The median value of the residual is minus 0.1252. The third quartile of the residual value is 1.4096, and the maximum residual value is 6.8727. Next is coming the coefficient table. There you can find we are having the intercept value 37.2851. The weight value is minus 5.3445. This is the standard error column. Next column is the t value column, and this is the p value. So you can see here we are getting the t value also in case of regression. So what this t is signifying here? So here the t test and its p value is very important because it is indicating whether your intercept and the coefficient of your weight variable is significant or not. That means it is whether it is equal to 0 or not. This is what you want to check here. So what we are doing, we want to see this thing using the p value. So you can look at the p value, which is indicating 2e minus 16 in case of intercept, and in case of coefficient of weight, it is 1.29 minus 10. So I think it is quietly visible to us and understandable. It is giving us understanding that these two figures are less than 0.05. Right? You can find how many asterisks are there? 3. So 3 asterisk meaning is this value. That means your figure is even. This particular value is significant at 0.1% also. This is the meaning, right? So I can write here intercept, which is 37.29. I'm rounding it off, and the coefficient of weight, which is minus 5.3445 or maybe 34, right? I can write, yes. Intercept and coefficient of weight are different from 0. Or you can say, or significantly contributing to the dependent variable, which is MPG, right? So this is the meaning of this particular thing, right? Till here I am clear? Interpretation is clear? Is it fine? Shall I go ahead?
Yes.
Yes. Now you can find in the console we are getting the R square and the adjusted R square value. This is again we are interpreting because it is very important. So you need to interpret here the first value, which is the multiple R square, or only simply you can say it is the R square value. So R square is what? It is 0.7582. So when you are performing simple linear regression, that means when you are having only one dependent and one independent variable, you will report R square. But when you are having the multiple independent variables, you need to report the adjusted R square, right? So we will interpret this value. Now what this value says to us? Multiple R square says to us the percent variance explained by IV in DV. So I'll try to make it little more simpler for you. I can say this thing that 75.28% variance, that is change in MPG, is explained by weight. of car. Right? Means how much change is possible in the MPG, or how much influence the weight of car is making in the MPG of the car is approximate 75.28%. Right? So this much percent variance is possible in the MPG when we are talking about the, or when we are considering the weight of the car. So this is the meaning. Is it clear?
Yes, ma'am.
Yes. Next important thing is you can find in the regression, we are also getting the value of F statistics. So question comes, why it is coming here? So it signifies us the fitness of the model, right? Whether your model is fit or not. So you can see the P value here. P value is less than 0.05. So we will say this model is fit. Means this is a fit, right? And helping you to predict your dependent variable. This is the meaning. It is clear?
Ma'am, please repeat how you have concluded.
Okay. F statistic is 91.38 for the degrees of freedom 1 and 30. And the P value is 1.294 E minus 10. So I have seen this value. I told you this value is less than 0.05. Less than 5%, right? It is very small figure. So that way I said, if it is less than 5% of whatever is the level of significance you are considering, if it is less than that, you can say that your model is a good model. Your model is a fit model. Is it clear now, sir?
Yes, ma'am, clear.
Fine. Now we will move for checking the assumptions. Now, as I told you, most of the assumptions are based on the output of the regression. So once you are getting the output of the regression, you need to check the assumptions. So suppose I will check my first assumption using the function called plot, right? So I'm writing here, function is plot. It is requiring the regression result, comma 1. I think my fourth window is visible, right? Shall I go for the interpretation? Visible to all? May I go for the interpretation of this now?
Yes.
Fine. So you can see although the data is not appropriate here. Why so? Or the results are not appropriate here. Reason being, you can see interpretation is the middle line, which is the zero line. You can see the dotted small line is visible to you. This is the zero line. And this is the red line, which is visible to you. If this red line is almost following or parallel to your zero line, that means in that case, you can comment that your residuals are fitted, right? Here you can see this. Here you can see this line is forming a curve here, right? So that is a problem. Just a minute. I'll create all the plots which are important here, and then I'll talk about this. And the third one is done. Fine. So again, coming to the first graph, you can see this red line should be almost parallel to your zero line, but it is not that, right? So that is a problem. It is not following exactly the zero line. It is indicating that your residuals are not having the same variance here, right? Second thing is, I'll show you the second graph. This graph is what? This is indicating you that your residuals are normally distributed. You can find there is a dotted line visible to you, and then circles are there. Circles are almost overlapping your fitted line, right? That means what you can say, your residuals are following the normality, right? This is the Cook's value. Cook's value is generally, I'm writing here, Cook's value. It is helping you to see influential value. So whether you're just on it, मैम बस 5 मिनट लगेगा, मैं वाइंड अप. So we can say Cook's value is helping you to check the influential value in your data, means whether your data is having any influential value which is impacting your results or not. So this is generally calculated as 4 by n. N is what? Number of observations, right? So you can check how many observations or how many pair of observations you are having. You can check the length, and that way you can get the Cook's value, right? And then you can see this particular chart, which is looking at the fourth window. This is the Cook's value, Cook's distance representation. So whatever that value is coming, according to that, you need to check this, right? So whatever means, suppose I'm having the pairs. Suppose I'll 4 by, suppose I'm having 30 pairs. So this value is 0.13, right? Now you can check 0.13 is somewhere here, but some of the figures are going above that, right? That means it is indicating these are the figures, these are the values which can impact your regression model, right? These are known as the influential values. So you need to control these values, or maybe you can remove them to get the better results, right? So this way, these are the assumptions we have checked using the results of the regression. I hope I'm clear here.
Yes, ma'am.
Okay. So I think, sir, today I'm concluding as I am at outside. Multiple regression I'll cover tomorrow along with the whatever I'm going to discuss tomorrow. Is it fine? May I conclude now?
Okay, ma'am.
Fine. So friends, today we have talked about correlation as well as regression. I told you correlation can help you to find the degree and direction of the relationship between the variables. There are multiple types of correlation: simple, multiple, partial, linear, non-linear, positive, and negative. We have tried, I tried to explain you the meaning of all the types of correlation. I told you correlation can help you to understand the relationship, but it is not a causation. Cause and effect kind of relationship we cannot understand using the correlation. That is not the capacity of the correlation, right? Then we have talked about we can measure the correlation using the Karl-Pearson's coefficient of correlation, and we are representing it by the small r. R value minimum can be -1, maximum can be +1, right? Using the core.test function, we can perform the correlation and we can interpret it, right? Then I talked about the regression. I told you regression is helping you to find the cause and effect relationship between your variables, right? So regressions are of various types in the statistics, but we have talked about only two, that is linear, simple linear and the multiple linear. Today I covered simple linear regression, where I told you that if you want to see the impact of one independent variable on dependent variable, you are using the regression, right? Then we have talked about the assumptions of correlation. Generally, not all, but main assumptions of the regression are roaming around the regression values, right? And we have seen LM function is we are using to find the regression between the two variables in the R programming, right? So this way we have explained you this. Ma'am, just winding up, coming. So this way we have seen the simple linear regression today, right? Now tomorrow, I think a few things which I'll try to cover those things tomorrow along with tomorrow's topic, right? So this is all from my side. If any queries, I think I can take. If not, I'll wind up the session for the day. Tomorrow we are meeting for the last session. Yes. Any questions from you people? Any questions?
Ma'am, tomorrow at what time, ma'am?
Ma'am, same time. Ramya ma'am, same time.
Oh, okay, ma'am. Okay, ma'am.
Okay. Thank you so much, ma'am. Any other query? Okay. If no query, friends, I am leaving, right? The meeting. Tomorrow I'll meet you for the last session and I'll cover tomorrow's topic along with today's multiple linear regression. Fine? Hari sir, it is okay? Anjali ma'am, fine?
Yes, ma'am. Thank you.
Yes, ma'am.
Thank you, sir. Yeah. Yoga sir, I think I'm done for the day. I have to leave early because I need to catch my bus. So I'm winding up the session. Thank you so much, everyone. Yoga sir, thank you.